So we're starting today's class. It's quite late, 9:30. We had to shoot the time for my shortcomings. We're gonna try to see the cautious law part for today's class and go ahead with the problem solving. তোমরা এখান থেকে কি কি অ্যাটেন্ড করছো বা কি কি পারো নাই সেগুলি বলো, or I can give you some numbers that we can discuss. কেউ কিছু অ্যাটেন্ড করছো এই পার্ট থেকে so far? এখান থেকে অ্যাকচুয়ালি টু বি অনেস্ট খুব বেশি কোনো কোশ্চেন নাই এখানে অ্যাকচুয়ালি আলাপ করার মতো. Most of the questions are actually pretty simple. নাম্বার 5টা ট্রাই করা যায়. নাম্বার 5টা ট্রাই করো সবাই, দেখো পরে দেখো, না বুঝলে আমি হেল্প করতেছি. তোমাদের ওয়ার্কশিট থেকে দেখো.
স্যার গ্রুপে 2টা কোয়েশ্চেন দিয়েছি, একটু দেখাই দিবেন?
দেখতেছেন আচ্ছা, আমি এটা আমার মতো করে সলভ করতেছি, তারপর আলাপ করতেছি. দেখো জারিফ বুঝা যায় কিনা। I chose the pathway that essentially contains both the R resistors, build up the second equation for Kirchhoff, that total voltage drop equals to total voltage gain, and then solve the equation for R. The reason I did not choose any of the other pathways because we do not know the value of the other resistors. The question don't give us those values. So even though do know the currents for any of the other pathways, without knowing the resistor, that current doesn't practically help us much. বুঝা যাচ্ছে?
জি স্যার, বুঝতে পেরেছি।
All right. Here we have 1 ampere. Into 2 ohm. হ্যালো, না ক্লাস মাত্র শুরু করলাম। আমি একটু বিকালে বেরিয়েছিলাম, ক্লাস নিতে পারিনি। 5:30 ক্লাস, সেটা 9:30 দিছি। ক্লাস শেষ হতে দেরি হবে, 11 বাজবে। হ্যাঁ। কারেক্ট আছে কি ডি দেওয়া?
স্যার ডি।
কারেক্ট আনসার কি দেওয়া, মানে আনসার কি জানো?
না স্যার।
এটা একটা ইয়ার কোশ্চেনের কোশ্চেন, খুঁজে বাই করা যাবে কিন্তু খুঁজতে হবে। আমার হিসেবে 13 আসে। এটা ওয়ার্কিং কিভাবে করছি বলি। Uh, the question says that this branch has a current of 1 ampere. I can see there is 2 ohm resistor over here. So the voltage across these 2 points should be 2 volt, 2 into 1. So 2 volt should be also flowing across this 1 ohm resistor. It should be applying across this resistor. So current for this branch should be 2 ampere. So the incoming current should be 2 plus 1, 1, 3 ampere. That current gets split into 1 ampere and 2 ampere because there should be 1 ampere over here since this is one full branch. So I can write this as 1 ampere for better understanding if you want. Then this 3 ampere was flowing in through here. I needed to find out what current was flowing through this branch to understand how much current was flowing through this branch. The reason I'm actually trying to find out the current through all of these resistors is if I uh, because I wanted to apply Kirchhoff's law to this loop. Actually, to measure the value of the V, we could choose any of the loops. We could choose, let's say, I'm gonna paste it over here to make a mess up drawing. To apply Kirchhoff's second law, we could either apply the law within this loop, we could apply it within this loop, I mean, this pathway, or we could also do it in this whole big pathway. I ultimately used the largest path just because I did, but I could do it by the smallest loop as well. But to do that, we had to find out what is the current flowing through these components. That was very important. Finding out the current through these branches were not very essential, but other than finding out these currents, it was quite difficult to find out how much current was flowing through the other ones. So that's why over here I applied Kirchhoff's second law for this green loop. So this small middle rectangle, middle square. So if we have a look over here, what I did is that I started the observation from here. So 1 into 3, let me use green, 1 into 3 multiplied by 1 into 2 minus I into 5. So I assume this current to be I. This is a variable, and the resistance was 1. I into 1 equals to 0 because this is the loop direction that I'm considering, and this is the current direction that I was considering. So loop direction was opposite to the current direction, assumed current direction. That's why it was considered as a negative voltage drop, and the same directions were placed at positive voltage drops. All of this sum was equals to 0 because within this loop we don't have any source. So we get I equals to 5 ampere. এই পর্যন্ত বুঝছো কিনা?
জি স্যার। জি স্যার।
এরপর আমি পুরা এই আউটসাইড লুপটার ভিতরে ফর্মুলা অ্যাপ্লাই করছি। পুরোটাতে অ্যাপ্লাই করলে হয়তো এই পিচিটাতে অ্যাপ্লাই করলে হয়তো either way you would get that this V value would be 13 volt. So that's my best capability. I think the answer is supposed to be 13 volt.
So the answer is 13.
আচ্ছা মিলছে?
হ্যাঁ।
আচ্ছা তা তো হয়েছে, বেশ খুশি হইলাম এই আর কি। uh, I'm not sure if there is a shortcut, I mean much less much more easier or less workable way to solve this question. There might be, but this is the way that popped in my head, so I went for it. দেখো যাই বুঝা গেছে কিনা?
জি স্যার, বুঝতে পেরেছি।
Beautiful. So let's tie the questions from the worksheet. If you have any questions, we'll pick those up and eventually go ahead forward. So which one do you think is the answer for this question? 5. To determine the ratio of V1 by V2 of the potential difference across R1 and R2, a point is found on X where at which the lamp is off. Lamp is off means there is no current. This is our null point. The point at a distance X from the X, what is the value of the ratio of V1 by V2? So V1 by V2 should be directly proportional to their length ratios of this wire. So X divided by the remaining. So the remaining will be L minus X. So I think D is the correct response as far as I'm concerned.
ইয়েস স্যার। স্যার ল্যাম্পে কারেন্ট থাকবে না কেন?
বুঝি নাই।
কোন কেসে ল্যাম্পে কোনো কারেন্ট ফ্লো করবে না?
ল্যাম্পে কারেন্ট ফ্লো করবে না যদি ল্যাম্পের দুই পাশের ভোল্টেজ ভ্যালুগুলো ইকুয়াল হয়। মানে হচ্ছে, let me just show you. The lamp will have zero current if the voltage across the lamp is zero, which means the value of voltage at this point and at this point are exactly equal to each other. So there is zero voltage across the lamp, hence the current would be zero. This would essentially mean that the voltage ratios between these 2 points is exactly equal to the voltage ratios of these 2 points. Or in other words, you can say their lengths are proportional because for the same current, voltage is proportional to R and R is proportional to L. So ratios of voltage can be given by ratio of lengths. In this case, the L1, which is this ratio, this length is X, and the L2 is this much, which is L minus X. Okay, sir.
জি স্যার।
Good. Did I mark number 7? I did not mark number 7. I should have marked number 7. Achha, although I did not mark number 7, I want you guys to try to add number 7. Number 7 to try koro shobai. It's a good question. To be honest, number 8 টা না দিলেও হইতো। Number 8 খুব dumb একটা question, but still number 7 to try করো right now.
Sir, I take it 10.5.
Yes, I think we are doing 10.5. I believe. Yes.
আমার বুকগুলোতে 10.4 পর্যন্ত স্যার।
কেমনে 10.5
না
তো
স্যার,
সব।
নেভার মাইন্ড, পেয়ে গিয়েছি। আই এম সরি, আই এম এক্সট্রিমলি সরি।
It's okay. Nice. কি আসছে, এটার আনসার কি হবে?
ডি হবে।
কারেক্ট আনসার ডি হবে, বাট এটা কি সবাই বুঝছো কেন ডি হবে? এটা আমি আলাপ করছিলাম নাল মেথড পড়ানোর সময়, যে পড়ানোর ওই ভ্যারিয়েবল রেজিস্টারটার পারপাসটা কি। কারো কোনো কনফিউশন নাম্বার 7 নিয়ে? If not, anything else within these other numbers? 11, 12. Did you kids see my new cover photo? It's nice.
স্যার কি ফেসবুকে?
Haha.
হ্যাঁ স্যার।
Acha, apparently you are not asking any questions, so you are not saying anything. So I might as well move to the paper 2 questions. Should I?
স্যার 11টা, না স্যার 11টা।
11 দেখবো. A potentiometer is used to use as shown to compare the EMFs of two cells. The balance point for cell X and Y are 0.70 meter and 0.90 meter respectively. If the EMF of cell is 1.1 volt, if the EMF of cell X is 1.1 volt, what is the EMF of cell Y? Now let's try to understand this problem carefully. What we need to understand is that this is the long resistance wire. I mean, let me just label it with red maybe. This is the long resistance wire within which the driver cell's total terminal voltage is evenly distributed. Of this total voltage drop, so we'll have that voltage distributed evenly or uniformly across the whole length. The question says that cell X has has an EMF of 1.1 volt. Both of these galvanometers are reading zero. That already tells that the balance point. The word balance point means that these are the points where this reading is zero, this reading is also zero. This cell has a voltage of 1.1 volt or EMF of 1.1 volt, which is happening for a length of 0.7 meter. Now, just a bit earlier, I showed you that voltage is proportional to resistance because there is a series wire over here, which is also proportional to length. So, which means whatever the voltage that this driver cell is able to create within this much length of wire, that amount of voltage is exactly 1.1 volt. So, what we're trying to find out is that what should be the voltage or EMF of cell Y. So, I can write Vx by Vy equals to Lx by Ly, because ultimately voltage is directly proportional to L. To be more understandable, I can write that EMF of X should be equal divided by EMF of Y. The reason I can replace the voltage with EMF, because in this case we have reached the balance points, which means there is no practical current flowing through this battery, so there is no voltage drop due to the internal resistances. So that's why the terminal voltage and the EMF can be considered to be equal. That's why I could bring this ratio over here. If this thing was not at an balance point, then we could not write this part. But this would hold true for every case. Voltage proportional to length is applicable for a single wire in every case. So if you understand this ratio properly, if you do understand this ratio properly, then the rest of the part is pretty simple. Just put those values. The EMF of say is 1.1 divided by EMF of Y, which you're trying to find out. Length for this thing is 0.7, the other one is 0.9. So you just do the ratio and find out the value.
Sir, D answer.
Yeah, what about the ratio gives you? বুঝা গেছে?
জি স্যার, আমি ড্রাইভার সেলের ভোল্টেজ 1.1 ভাবছিলাম।
না, কোশ্চেন
কোয়েশ্চেন করতে ভুল হয়ে গেছে।
সমস্যা নাই, জাস্ট বি কেয়ারফুল। তারপর
স্যার করছি।
আচ্ছা, বাকি দুটো প্রবলেম করে দেখো, আটকালে বলো, আমি হেল্প করতেছি, না মিললে বলো, আমি হেল্প করতেছি। ইন দ্য মিন টাইম আমি পেপার 2 এর কি কোশ্চেন ডিসকাস করা যায় সেগুলো একটা আইডিয়া করি।
পেপার 1 শেয়ার।
ওকে, পেপার 2 এর নাম্বার 1, নাম্বার 2 সি এগুলো ট্রাই করা শুরু করো। পেপার 2টা বাই করো, এলসি পেপার 2 নাম্বার 1টাকে ট্রাই করো।
So part why number one না?
হ্যাঁ 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 হ্যাঁ, পার্ট 1 পার্ট 2 তে একই নাম্বারিং মেনটেন করা, জাস্ট ওয়ার্কশিট দুটো অনেক বড় ছিল। পরে আমরা যখন প্রথম থেকে স্ট্যাপলার করে স্টুডেন্টদেরকে ওয়ার্কশিট দিতাম, তখন তোমার এই পুরাটা একটা স্ট্যাপলার ধরতো না, ওই জন্য পার্ট 1 পার্ট 2 করা হয়েছে, বাট দ্য নাম্বারিং ইজ কন্টিনিউয়াস। সবগুলাই আমাদের লাগবে। এই যে P2 তে এই নাম্বারগুলো দিলাম, এই নাম্বারগুলো মোটামুটি যদি তোমরা করতে পারো তাহলে আশা করা যায় যে তোমরা বাকিগুলাতে আটকাবা অনেক কম। তারপর আটকালে আমি অবশ্যই হেল্প করবো। তো আমি এটা স্ক্রিনশট মেরে আমি ইয়াতেও সেভ করে দিচ্ছি, কোথায় মেসেঞ্জারে পাঠিয়ে দিচ্ছি, এটা প্রতিদিন আমাদের এই লিস্ট খুঁজতে না হয়, মেসেঞ্জার থেকে এটা ট্র্যাক করা যায়। ও দাঁড়া, থ্যাংক ইউ। এই
You're welcome, sir.
আচ্ছা, আমি আপাতত ভিডিও রেকর্ডিং পজ করতেছি, তোমার প্রবলেমগুলো কিছুক্ষণ ট্রাই করো, সলভ করা শুরু করলে আমি আবার রিজিউম করবো। So using 100 ohm, using a lot of, we have access to a lot of 100 ohm resistors. Using some sort of combination, we have to produce 200, we have to produce 50, we have to produce 40. Producing 200 is very simple. You can see that this is double that value, so you just draw a series combination of two resistors and you are good. Sometimes it's recommended that you give two circles over here to make sure to give an idea for the examiner that where the connection points are supposed to be, because this can be quite important for certain other circuits, but not for this one. For this one, if you don't give the circles, it's good. But drawing the circles means that you are pretty really, what can I say? You are aware of how you should draw the circuit diagrams. Similarly, 50 ohm resistance can be very
Circles গুলো কি বুঝাই বুঝি?
the circles represent where the connection points are supposed to be. For example, let's say আমি মনে করো একটা সার্কিট ডায়াগ্রাম আঁকলাম এরকম, ঠিক আছে? এখন আমি তোমাকে বললাম যে the resistance of this circuit is something. Now, this could mean I could connect a ohm meter between these 2 points. I could connect an ohm meter between these 2 points. I could connect an ohm meter between these 2 points. So there can be a lot of different connection points. But whenever you give these two circles, it means that you're defining that the resistance across these 2 points, the resistance is 200 ohm. বুঝছো?
Yes, sir. Thank you.
আচ্ছা, এটা একটা। Then 40 ohm can be achieved in a lot of different ways. One of my recommendation, I mean, achieving 40 ohm can be logically achieved by a lot of different ways, because they haven't said us that we should use the least number of resistors. So one of the ways that this can be achieved, I mean, my recommendation towards doing this expression, that you try to slowly complicate the circuit. Slowly complicate the circuit means that so far this was one of our circuit, this was one of our circuit. If we introduce one more resistor, let's say if we want to make combination of 3 resistors. We do understand that 40 ohm cannot be achieved by 3 in series. We do understand 40 ohm cannot be achieved by 3 in parallel. So try the other 2 versions. So how about you try this one and you also try this one. This is the next complicated circuit using 3 components. Now I do understand that the resistors of common resistors of this thing should be 150 ohm. I can see it right here, but I cannot do the calculation of this one in my head because I do understand this branch has a resistance of 200 ohm, this one branch has a resistance of 100 ohm, 200 আর 100 ইনভার্স করে যেটা ইনভার্স করে অ্যাড করে যেটা আসবে সেটা হচ্ছে আমাদের কমন রেসিস্ট্যান্স অফ দিস হোল থিং। তাহলে এটা কত হবে? So if you check this, you will find out that this one becomes to be 40 ohm. So drawing this one over here with 2 circles at 2 ends would suffice the requirement. But let's say you don't remember this thing or this thing doesn't pop in your head. So how do we approach this problem? There are a lot of different ways. 40 ohm can be considered to be 20 plus 20. Getting 20 ohm out of 100 ohm resistors is pretty simple. You just draw 5 of them in parallel, right? This
Yes,
one
sir.
has 20 ohm resistance. Then draw this exact thing once again on the right and you're good. So yeah, so place it up over here and you have got your 40 ohm resistor. If you want to make it even more complicated, you can consider this thing is made up of, let's say 40 ohm can be made up of, let's say 10 plus 10 plus 10 plus 10. You do understand this would require to draw a lot more. You can get 10 ohm out of 100 ohm resistors if you connect 10 of them in parallel, and if you attach 4 of those parallel combinations in series, you can get 40 ohms. Do you get my point? So mathematically speaking, that there can be a lot of different ways by which you can achieve 40 ohm resistor. Any of relevant, actually logically acceptable answer is okay. So what I recommend, that do whatever that comes in your mind and go for it. Don't overthink the process. As long as your answer is good, it's good. But if the question did ask you that you have to draw a circuit which has the least number of 100 ohm resistors, you have to see that to achieve this thing we had to use 10 resistors, whereas within this case we only used 3 resistors and that's it. So if we had to use the least number of 100 ohm resistors, then this would be the only preferable choice. But if you had, if the,
Wait, that's not 40 ohms.
that's not 40 ohms.
No, that's
আর একটা 100 ওহম দিতে হবে প্যারালাল।
আর একটা প্যারালাল আর একটা 100 ohm দিতে হবে।
তাহলে একটা 100 ohm দিতে হবে। আচ্ছা, তাহলে হয়।
Yes, sir.
এই জিনিসটা বললাম যে achieving this thing would require quite a bit of trial and error. There is no, I mean hard and fast mathematical way by which you can reach to this answer. So whether you're going to try and attempt multiple different simple registers, or you actually mathematically set away in your head something like this and eventually go for that drawing, that is your decision. I personally like this one better because this does not require any trial and error, because trial and error is a good thing if you can reach to your goal within couple of, or let's say 2 or 3 attempts, but there is no guarantee that you might actually get there. So that can actually make things really cumbersome and difficult and time wasting. So I think I made my point. বুঝে গেছে এই প্রবলেমটা?
জি স্যার।
বিউটিফুল। পরেরটা দেখি। পরেরটা অ্যাকচুয়ালি সহজ, পরেরটাতে খুব কঠিন কিছু নাই। কোশ্চেন টোশ্চেন দেওয়া আছে, এগুলো ভ্যালু বসালে চলে আসবে। এখানে রেজিস্ট্যান্স দেওয়া আছে, পাওয়ার দেওয়া আছে। So P equals to I square R. That is the current in the circuit. Power distribution in each of the 25 ohm resistor. So you just have to halve that current and then calculate I square R again, and that gives you this value. It's just simple. Okay, I'm interested for 2C. 2C actually করার জন্য আমাদের এই ম্যাথটা পুরোটা করে আসতে হবে. This is a very simple math regarding the resistivity equation, R equals to rho L by A. So you just go ahead and do this calculation step by step, and then eventually calculate the length of the filament over here. What is really, really, really important that in this question they have already given us the radius of the wire. So radiusটাকে আমাদের cross section area তে convert করে নিতে হবে. Lucky for us, they have already given us this quantity in meter unit, so you don't have to do any meter conversion, but there is a tenths power. Don't forget to include this in your equation with brackets. This number C is what I'm interested in. This question number C, comment on your answer to B. Now this type of question can actually set you off your comfort zone. I mean, what does it mean by doing a comment? I mean, what they are actually asking. I can do a lot of comment over here that, let's say that, I mean, comment means what? Comment can be a lot of things. This is one of the, what can I say, very deceptive ways to set up a question that the examinees can find to be too difficult to respond to. I don't like this question, honestly speaking. But the only answer that is logical to give over here, if you actually do this whole calculation, you will ultimately find this length to be in quite large. Just to make, not to do the whole mathematical calculation to save time, I'm going to take this value from the mass scheme. So let's say here is the electricity mass
0.137 meters, session.
0.127 meter, which means 13.7 centimeters. No, how much? Yes, 13.7 centimeter. 13.7 centimeter. Now what do we need to understand that 13.7 centimeter is actually quite long. If you have a ruler around you, you can take it out and have a look. The 13.7 is actually quite big. A filament lamp is usually never that wide, and the filament is usually placed in between two very in a very confined space. The part of the filament lamp that glows is actually very small. So the only logical thing that it can be made into comment as per the Marr scheme also is that the filament lamp was coiled so that it could be accommodated within the small space inside a filament lamp bulb. Do you get my point? The length of the filament lamp was this much, but it is actually inefficient or unnecessary to actually accommodate that much long of a wire in its original lengthy shape. So if we actually did keep this wire straight, then the filament lamp would have to be pretty large. We do not appreciate that. So we actually coil the filament lamp, and that gives us the thing. Actually, filament lamp is actually coiled in a very interesting manner. For those who have ever actually physically taken out a filament lamp's broken wire, and if you have a look at it, you know. And for those who haven't, have a look over here. A filament lamp's coil is actually coiled in this manner. There is a coil which is coiled. Do you understand what I'm drawing here?
Yes, sir.
It's a coiled which is coiled, and so that you can really accommodate a huge length of wire within a very short distance, hence having a pretty strong intensity of light within a small bulb. Okay, then after this, which one is the problem? 5 is a pretty interesting question. Did anyone attempt number 5 yet? If you haven't, I want you to take some time and think about this question. I'll tell you the solution, but I want you guys to think about this question. You can have a look at the Marr scheme as well and try to figure out how does that Marr scheme actually make sense. Please try the question number 5. I'll help you for this one, but I want you to try it first. Everyone, take time. কি বুঝছো বলো? Number 5. Number 5 টাইম বের করে নিচ্ছি. All right, the question says that one of the lamps is faulty. In order to calculate the fault, an ohmmeter, ammeter that measures the resistance current between the terminals X and Y, which measures resistance, the ohmmeter causes negligible current in the circuit. Figure 7.2 shows the reading of the ohmmeter for different switch positions. The first row is easily understandable, that whenever all the switches are open, the meter reading is supposed to be infinite. Of course, because there is no current that can flow, so the rest is infinite. The second row, have a look at second row. Closed, open, open. So which one is closed? this one is closed. When this one is closed and these two are open, current can only flow through this pathway. Have a look at this pathway, which means in that case, the current will only flow through the lamp A, and the ohmmeter is measuring to be 15 ohm, which means the resistance of this bulb is measured to be 15 ohm. Okay, the question already told us that they are all identical lamps. Then for the third row, it says open, closed, open. So we had this one open. So let me just erase that. Erase that. So S1 is open, and this one is closed, and this one is open, which means in this case the current will have to flow through from X to bulb A all the way up over here. It cannot flow through this pathway, so these pathways are out of question, and current will flow through the bulb B and eventually reach to point Y. So in this case, bulb A and bulb B are currently in series combination. So combined resistance was measured to be 30 ohm, which also totally makes sense because the one of the bulb has resistance of 15 ohm, this one has a bulb of 15 ohm, so this is 15 ohm. Then the fourth row, open, closed, closed. So this is open, which means current cannot bypass, and both of these are closed. Now have a look. Whenever both of these are closed, you have to understand that these two bulbs are currently in parallel, and this bulb is passing through in series. So this parallel combination is in combination within series. So logic tells us the combined resistance is supposed to be 15 plus 7.5, which is should be equals to 22.5. This is supposed to happen, but the meter is reading is giving us 15 ohm only, which essentially means there should be some fault within the bulb C, because bulb C is not behaving as it is supposed to behave. It is behaving as something else. So identify the faulty lamp and measure nature of the fault. After the faulty lamp is C. What is the nature of fault? Now this is the interesting question. Will you say that the bulb C is broken? If you say the bulb C is broken, let me tell you what it means. Let's say this is a filament lamp. This is a glass enclosure. These are two plus and minus wire, and in between these two wires we have the filament. Saying that the filament lamp is broken basically means that there is a disconnection in the filament. Having a disconnection within that filament practically means that we have infinite resistance for this filament lamp. It's an open switch. So that basically means the same thing as S3 being opened. Now, if you have a to understand, if you say that filament lamp C is broken or filament is broken, that would mean the whenever both of these switches were closed, even though the switch is closed, the resistance of this branch would be infinite. So these two branches would pretty much behave similarly. So the combined resistance of all of these three pathways open should actually mean the resistance of this pathway, because no current should flow through this path. That should give us a resistance of 30 ohm, but that's not the case. How much did we get? 15 ohm. This is disturbing. I'll tell you why this is disturbing. We're counting the ohm meter across X and Y terminals, which is good. And whenever both of these switches are closed, bulb A is having a resistance of 15 ohm is showing up over here, but the entire resistance of this parallel combination happens to have become 0 ohm. Try to understand. Bulb A had 15 ohm, which we already decided over here. This 15 ohm represents the resistance of bulb A. This 30 ohm represents the combined resistance of bulb A plus bulb B current in series. But whenever we bring the bulb C within the circuit, the combined resistance of this parallel combination becomes 0. Now, how can you have a parallel combination's resistance become 0? A parallel combination's combined resistance can only be 0 if one of the branch is a short circuit. Because if one of the branch is a short circuit, any of the branch, I mean, you could have a resistance over here, you could have another branch that is short circuit, doesn't matter. A short circuited branch means all the current that will enter this combination will practically flow through this short circuit path and nowhere else and go out. So this essentially means that bulb C was having a short circuit, which practically made the combined resistance of this whole combination to be 0. As a result, whenever we had open, closed, closed, we included the bulb C within the circuit. The final resistance was only 50 ohm, which basically represents the resistance bulb A. So nature of fault হচ্ছে shorted, not filament broken. If it was filament broken, then it should be 30 ohm. But because it is 15 ohm, this should be shorted. Shorted basically means that somehow these incoming wire and this incoming wire overlapped and touched each other, and as a result there is no resistance within this bulb, and as a result this whole parallel combination is also having zero resistance. এই ডিসকাশনটা বুঝা গেছে কিনা লজিক্যালি?
জি স্যার
Sir,
বুঝেছি।
জি স্যার।
হ্যাঁ বলো।
sir, would you 15 plus 7.5? 7.5 টা কই পেলেন?
যদি ফিলামেন্ট ল্যাম্প সি ঠিক থাকতো তাহলে এই প্যারালাল কম্বিনেশনের রেজিস্ট্যান্স কত হতো? এটাও 15, এটাও 15, এটাও 15, এই দুটো প্যারালাল কম্বিনেশন হতো 7.5, 15 ইনভার্স প্লাস 15 ইনভার্স হোল ইনভার্স।
বুঝেছি স্যার।
সেই কেসে এটা হওয়ার কথা ছিল যদি সবগুলো বাল্বই হেলদি থাকতো, বাট এটা হয় নাই। তার মানে হচ্ছে সি বাল্বে প্রবলেম আছে, দ্যাটস আই রোট সি। হোয়াট ইজ দ্য টাইপ অফ প্রবলেম, ওটা বোঝানোর জন্য আমি এই বাকি কথাগুলি বললাম।
বুঝেছি স্যার।
Okay. B number is also a very important question. This is a very important question which goes all the way up to your lab experience as well. Suggest why it is advisable to test the circuit using an ohm meter that causes negligible current rather than with a power supply. Try to understand, an ohm meter by default, by its own virtue, produces a very small current within the circuit, which means even if the circuit has a wide or has a top to bottom or start to end short circuit, the current that will flow through the circuit will be very small, so that will not cause your circuit or your component or equipment to burn up or overheat very fast. That's not going to happen because the ohm meter by its own property creates a very small amount of current. So but this is something that the ohm meter can do. But if we did connect a full supply, let's say a 4 volt or 6 volt or 12 volt supply across point xy, for any of the shorted path, if there is a direct shorted path from the start and the end point, infinite current will flow for a very short time. Or to be honest, infinite current is actually a pretty theoretical term. We can say that very large amount of current would have flown through these 2 points. I mean, here's the deal. Try to understand this thing very clearly. Bulb A over here is placed between x and y in a series combination. For any current to flow from x to y, x through y, the current must flow through bulb A. There is no alternative path. The current has to pass through bulb A. Now we do not know which of this bulb was problematic, but have a look. If it so happened, which did not happen in this case, but if it so happened that bulb A was shorted, তখন প্রবলেমটা কি হলো চিন্তা করো তো। Let's say bulb A is shorted and we did connect an actual battery between bulb X and Y. This would cause for this connection closed open for the for the battery to heat up and melt and burn, not essentially explode, but it would be destroyed. This bulb battery would be destroyed. If you wonder why, if this bulb was shorted, whenever we're gonna close only this switch, large current will flow through this pathway, like huge current. Now you need to understand that this whole pathway doesn't provide any resistance, but battery by its own virtue has a thing called internal resistance, which means all the current that is actually going to flow up, actually this is going to be the heating effect within the battery, and this will heat up the battery really, really fast, leading to a lot of possible dangers. So because we do not know which of the bulb is faulty and we do not also know what is the type of the fault, other than using a bad power supply, it is good to use an ohm meter so that small current will not ultimately damage our equipment. এই আইডিয়াটা বুঝা গেছে কিনা পোলাপান?
জি স্যার।
মার্ক স্কিমটা একবার পড়ো, এই বি নাম্বারের মার্ক স্কিমটা পড়ো, এক্সামিনেশন রিপোর্টটা পড়ো, দুইটাই পড়ো, সময় নিয়ে পড়ো, কিছু না বুঝলে আমাকে জিজ্ঞেস করো, টেক টাইম, গো হ্যাড। কি 5 ছিল না কত ছিল এটা? 5 এর বি
স্যার সাপ্লাইয়ের মধ্যে ফিউজ কানেক্ট করা যায়?
হ্যাঁ মনে
ফিউজ
করো
না লাইভ ওয়্যার কানেক্ট করে?
না 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 না, বলি তোমাকে, সেটা হচ্ছে তুমি যে কোনো ডিভাইসের মধ্যেই ফিউজ কানেক্ট করতে পারো ফর সেফটি। ফর এক্সাম্পল আমাদের ফর এক্সাম্পল দ্য variable power sources that we use in our lab, which are pretty large boxes, they have fuse within them. And or if you think that any the inverter of an IPS machine, that has a fuse within itself. An electrical device, if you want to safekeep it, you can connect a fuse within the device to limit the current. That if the current goes higher than an expected value, the fuse will blow, and thus saving your rest of the equipment. You can connect fuse in any electrical equipment if necessary.
বুঝেছি স্যার।
B number examination for the candidates were very aware of the danger by electrocuted, and many warned the damage who sorry and many warned of the damage which might be caused. Very few, however, recognize that the predicted damage might arise only if lamp A was shorted. So that's why in the answer you can see in mark scheme that lamp A, for the first mark, lamp A is underlined. Because like I said that for this circuit and for the type of connections between X and Y, where we are connecting our source or or ohm meter, only we would only run into this problem of overheating or very massive value of current only if lamp A was shorted. But any other bulb being shorted doesn't actually pose a problem, because if lamp A is all right, there is a default resistance in your pathway, so you cannot have a very large current, so thus your equipments will not be damaged. But if lamp A was shorted, then you would run into some pretty large, pretty huge problem. That's the important bit to understand. আচ্ছা, এরপর আমরা একটা কোশ্চেন দেখি 6. আচ্ছা, তোমাদেরকে কোশ্চেন নাম্বার 6টা নিয়ে আমি একটু বুঝাই, তারপর তোমরা নিজেরা অ্যাটেম্প করো। কোশ্চেন নাম্বার 6 এর কনসেপ্টটা হচ্ছে, this is a battery charger and this is a car battery. We are going to apply this EMF across this car battery. Both have some internal resistances, and this is going to cause a current out of this pathway in this manner. So obviously for this circuit, 14 volt, for the charging process to happen, 14 volt has to be stronger compared to the EMF of this cell, so that this 14 volt would be able to overpower the EMF of this car battery and actually cause a opposite current compared to the direction of the car battery, which will basically reverse the chemical reaction within the battery and store energy within the battery. So this is basically how it's going to work out. That's how actually happens. And this is the same thing that happens whenever we recharge our cell phones. Same stuff. Now in A it says at the beginning, আচ্ছা এটুকু আমি তোমাদেরকে বললাম, তোমরা একটু 6 নাম্বারটা ট্রাই করো and then I'm going to help you. সব পারছো অথবা এখনো করা হয় নাই কোনটা?
করা হয় না।
আচ্ছা করতে থাকো। এই কোশ্চেনটা লেংদি, আই এগ্রি, সো টেক ইউর টাইম।